Hello everyone. So let us continue with our topic program linking loader. Before we continue further, I request you all to go through this video because this is the part 1 which describes the 50% of the explanation which I covered in this video, a program linking loader part 1. So now I'll be covering the part 2, so which is an extension of the explanation what I made in this video. So today let me continue with that. So whatever I had covered in that video, it is what under the program linking. These are the 3 individual programs considered, and when these 3 individual and independent programs wherein they are dependent on each other by making use of the reference symbols, those 3 programs, when it is given as an input to the assembler has generated the 3 individual programs or 3 individual object programs for the 3 individual source programs. So that is what we saw in the previous video. Today, now let us take up this next session as such. How does this linking loader will link these 3 object programs together and load into the main memory? So before we see the actual process of loading into the main memory, so before we see about the actual process of loading these 3 object programs into the main memory, so here I want to highlight something as usually the linking loader performs its action in the 2 passes. I call it as pass 1 and pass 2. What happens in pass 1? What happens in pass 1? It only assigns the addresses. It only assigns the addresses to all the reference symbols, are called as external symbols, and those symbols are made to be stored into the ES tab. ES tab is the data structure used by the linking loader, which you call as the external symbol table, or you may also call it as external reference symbol table. So this is the data structure used by the linking loader. So in the pass 1, it assigns the addresses to all the external symbols, and those will be stored to the ES tab, external reference symbol table. That is what happens in pass 1. What happens in pass 2? That is where the actual process of linking and the loading will happen, and there may be the possibility of relocation based on the memory constraints. So so per suppose again, so moving together, so however I said ES tab, which is external reference symbol table, which is to store the name and addresses of each and every external symbols whatever you used in the control section. With this ES tab, we'll be making use of the 3 variables here. Those are considered as program address, CS address, and the executable address. However, the name itself specifies the program address, that is the beginning address in the main memory from where the loading has to begin. So that is what a program address. I hope you understood from previous concepts in the relocation itself. I said, so as a part of loading, the loader will fetch the beginning address from where the memory from where the object code has to be loaded, that is from the operating system. So this program address is the beginning address in the main memory where the loading has to start. So that is what this will be fetched from the operating system. Then you have a CS address, as it's specified as control section address. So this is the starting address of the each individual control section. This will be the starting address for the each individual control section. Then we have the executable address. Once after the linking and loading is completely performed, then where exactly the actual execution process should begin, that is specified in the form of executable address. Like this, we'll be making use of 3 variables with the 1 data structure, which is ES tab. So that is what the data structure and the variables which we are going to use. Again, elaborating in detail, in the pass 1, as for the purpose of generating ES tab, remember we will be dealing with, so even before that, I hope you understood from this diagram what is the input to this linking loader. It is the object programs, and multiple object programs are the input to the linking loader, and those will be loaded to the main memory one after the other. At the same time of loading, the linking will also be performed. So linking will also be performed, so at the time of loading. So in that perception, so input to the linking loader are these object programs. And what does the object programs contains? Object program contains nothing else than the multiple records, like starting with the header record, define record, refer record, text record, and the modification record and end record. So in the pass one you consider only with the header record and the define records only, whereas in the pass 2 you consider the text record and the modification record. That you keep in mind. So in the pass 1 you consider only header record and define record of the object program, whereas in the pass 2 you consider the text record and the modification record in the pass 2, which actually performs the linking and loading process. Now let us start. So when I say that again, so let us consider the normal object programs whatever we generated. So if you observe right here, this is the object program A, this is the object program for the program A, and this is program B, and this is program C. So we generated all these three in the last session in my part 1 session or part 1 video, which I elaborated this. So now I am taking up these three as the inputs to my linking loader. So if these are the three object programs, are the input to my linking loader, so how would I consider, or how exactly I am going to do this linking loader process? That is what my next step. So let me explain you guys with the algorithm. So this is what the algorithm of the pass 1 of linking loader. This is the algorithm for the pass 1 of linking loader. So here if you observe, so this is what the program address from where the object program need to be loaded to the main memory, or in the other way, let's say that the starting address from where the loading has to begin in the main memory. And usually who give that starting address? It is nothing else than the operating system. Here let me assume here as if the starting address, let me assume here that the starting address, which is let me assume that the operating system has given the starting address as 4000. So this, it means to say that the loading may begin from the 4000 onwards. So what I did, so the starting address is set as 4000 in the main memory. Then later what happens, so next line what you are doing, if you observe, so I am going to initialize that itself as the starting address for the first control section address. I will say that CSADDR. So this is what the control section address for the first control section or the first program. So that's what CS address is also 4000. Then what I will do until the end of input, this is very important, please make a note, this is not the end of the program, this is the end of the input, and my input has 3 object programs. Keep that in mind, my input has 3 object programs. So until I deal with, or until I work with all the 3 inputs or 3 object programs, this pass 1 will not be end, it will not be stopped. So as my input in my example, whatever I consider 3 object programs, it may be 5, it may be 10, it may be plenty. So, and it is not I am considering for each individual object program, I am considering for the entire input. And in my example, the input contains the input to this linking loader are the 3 object programs. So I need to work with all the 3 object programs. So first let me start with the first object program. And this is what my first object program. I'll consider it as a first object program. Yeah, this is what my first object program. So in this first object program, read the first header record. That is what you can see. Read the first input record, which is nothing else, read the header record. As soon as I read the header record from this, make a note of the CS length. So CS length, which is nothing as the control section length. From this you can make it out. So you can make it out from this as control section length. It is what? 63. So I'll say that CSLTH is nothing as 63. So from this I can make it out that the control section length is 63. Then what I'm doing, let me come back to my algorithm. What I'm doing, I'm just searching in the ES tab for the control section name. What is my control section name? It is the program A. So I searched in my ES tab. If it is already found, definitely I should raise the error, because so you cannot have the same symbol name, same control section name for the multiple control sections belongs to the same programs. So that is the reason I will be raising the error if the same name. What is the name I am talking about here? This is the control section name, which is program A. If it is already available in the ES tab data structure, so I will be raising the error. If it is not available, then what I am going to do? So I hope you are getting this point. So this is where I will be initializing this is where I initialize the CS address. Then this is where I set the CS length. Then this is where I will be storing. So as of now, there is the program A, which will be stored with the, if you observe this, you can see this. Enter the control section name into the ES tab with the, very importantly, with what? With the CS address. And what is the current CS address? It is what? 4000. So that will be entered to the ES tab. Program A and the CS address will be entered. Then until the end record, I will be reading the next record, and I also, very importantly, which record I am going to deal with? It is the defined record. From the defined record, read each symbol. You need to read the each symbol and check in the ES tab whether that symbol is already available, already exists in the ES tab or not. If it is exist, it is as usual, raise the duplicate symbol error. If it does not exist, so understand. So from this you try to make it out. From this defined record, what are the symbols here? It is list A and NDA, and the address of list A is 40 and address of NDA is 54. So I should make sure that list A and NDA are not already stored in the, are not already available in the ES tab. If it is available, I should raise the error. If it is not available, I should store them. That is what? List A, I should store this with what? With, if you observe, it is what? With what? With what? It is with CS address plus indicated address. What is the indicated address here? It is list A, which is indicated with what? 40 plus the CS address. What is the CS address for this? It is the 4000. So I will say that 4000 plus 40. So if I say that 4000 plus 40, what is the address? So what is the value? Obviously it is 4040. And there is one more symbol. If you observe, there is one more symbol. It is the NDA. In the defined record, there is one more symbol with the NDA with the address as 54. Even that, I assume that that is also not available in the ES tab. So I need to store with the CS address plus indicated address. Indicated address is 54. Likewise, I just need to store this list A and NDA, to the ES tab. Then later, so I'm done with in this object program A. So defined record contains only these two symbols, list A and NDA, with the respective thing. So I'm done with this. Control section A, object program of the control section A. If I am done with this object program of the control section A, so then I need to go to the control section B. If I have to go to the control section B, remember, so the control section A is already started from the 4000. So where does the control section B has to start? Where does the control section B has to be loaded? So for that you need to find out the starting address. That is what this line says. Add the current CS length. That's what length of the current control section. What is the current length of the current control section that we found here? It is 63, because from the object program itself it says that length of the control section is what? 63. So that itself you need to add. So now what happens from this line? from this line, what happens? It is CS address will become what? It is what? CS length will be added. So CS length, so CS address will become the CS, what actual CS address plus, so actual CS address plus the CS length. So what is the CS length? It is what? 63. In this example it is 63, so it will become 63. So this is what happened. CS address is updated with the added with the CS length. So then you need to check, is it end of input, is it end of the file? Obviously no, because we just worked with only one object program. That's what I said. Total there will be 3 object programs, so we just worked with the only one object program. So this past one has to be repeated for the next control section, object program of the next control section. This is the object program of the first control section, which is program A. So now we need to work with the program B as well. We need to work with the program B as well. So for that, again as usual, where does the control will go? In the sense, remember, the control will not go to the beginning here. Control will not go to the here, because this end has not taken care, I would say occurred. As this end is not occurred, so it will come back to this. It will come back to this begin. So it will begin the next input record from the next control section. As soon as it reads this, remember, as soon as it reads this, so I'll let me insert one more text record here. So yeah, so I'll just reduce the size so that it maybe I can fit it better. Yeah, so this is where I said this. Yeah, this is where I said the CS length, and this is where I said this. Fine, looks better. So I hope you are understanding now. So now I'll just create one more text record for the second control section. Remember, so now you just, if you observe clearly, so now as soon as this addition has occurred, what is the address, what is the value of the current control section? If you could able to get it, what is the value of the current control section? It is what? 4000 plus 63. It has become what? 4063. 4063. It has become 4063. Again as usual, you see the second object. This is the second object program. So from this, what is the length? It is what? 7f. The length of the second object program, it is what? 7f. So this CSLTH become 7f. Again, so what is the name of the program? It is what? Program A, PRGOA. It is what? Not GA, it is B. Yeah, it is PRGOB. And so now again, as you need to verify whether that program G is available in the ES tab or not. If it is available, leave it. I would say not leaving. So if it is already available, you need to raise the error. That is what this line says. If it is already available in the ES tab, raise the duplicate symbol error. If it is not available, what are you supposed to do? You need to add that with what? So enter that control section name. What is the here? It is program B. With what? With the CS address. What is the current CS address? It is what? 4063. Then you need to read the define record. You need to only bother about define record. I repeat. So from that define record, fetch the symbol. What are the symbols here? It is list B and end B with the address 60 and 70. So list B and end B. Check whether that list B and B are already available in the ES tab or not. If it is not available, what are you supposed to do? So store them. List B need to be stored with what? So list B need to be stored with what? CS address plus indicator address. What is the indicator address of list B? It is what? 60. And what is this address? What is it? It is CS address. What is this? It is 4063. I say it as 4063 plus 60. Whatever the address you get. Again what about the end B? End B again as usual 4063 plus 70. So that's the address which you supposed to, because there are the two symbols list B and end B in the define record of the control section B. That's what you did. Then later, so as those are only the two symbols we had in the define record, so that's what those two symbols are pushed to the ES tab. Then later, So again, as usual, you are done with the second control section. So you need to go to the third control section. For going to the third control section, you are supposed to know what is the CS address for this. How to get it? Again, as usual, add the CS length. What is the current CS length? It is what? 7F. And what is the CS address? So you will get 4063 plus 7F. Whatever the resultant value you get. So that's what this will be the address of the next control section. I repeat. So this will be the address of the next control section. When you add this 4063 plus 7F, you will get 40E2. You will get 40E2. So then again, as usual, you find the length of this control section, which is what you can observe. This length of this control section is what? 51. So CES LTH will become what? 50, 51 or 52? 51. Yeah. Next again, what is the name of that control section? It is what? Program C. Is it already available in the ES tab? I assume that it is not available. So I need to load that with the current CS address. What is the current CS address? It is what? 40E2. 40E2. Then again, read the defined record from this. So when you read the defined record from this control section C, there are the two symbols, which is end C and list C and end C, with the addresses as 30 and 42. With the addresses are 30 and 42. I assume that those are not already available. So list C, I need to store list C with what? 40E2 plus 60. Is it 60? No, it's 30. 40E2 plus 30. So understand? So I need to store this 40E2 plus 30. Then in the same way, so for the end C as well, when you store that end C as well, yeah, so 40, it is what? 40E2. Let me not be make any mistake. Yeah, it is 40E2, because when you add 4063, if you want to see it, you can just calculate. Yeah, this, let me take up the programmer view. So yeah, let me take up this hexadecimal. So what is this? 4063 plus 7F. 4063 plus 7. Where is F? Yeah, F. So we'll get as 40E2. Okay, so that's what 40E2. So that 40E2 plus, so if you observe, the address of that list seed is 30. What about the address of end seed is 42? So this, I'll say end C. So again, as usual, 40E2 plus 42. So like that, those list C and end C will be loaded. Again, as usual, you try to find out next CS address. Next CS address, how do you find it? 40E2 plus current length of the program, which is 51. So you may get something, but now already you are at the end of the input. So how many inputs you consider? 3 inputs, and you already done with the 3 inputs. So your loading process will be sorry, not the loading, sorry for that. So your pass one process will be stopped. That's what, as it is end of the file. So it will be stopped. What will be stopped? Pass one will be stopped. So this is what the pass one. See, from this, let me create the ES tab separately based on this. So let me create the ES tab separately based on this. So I'll say it as, yeah. So let me create a separate table based on this. Yeah, so as usual, program address, which is fixed, 4000 I just considered. Then let me call this as a control section name, which is control section, and this is what the symbol name. Then this is what address, and here I'll consider it for length. Yeah, so if you understand clearly what I'm trying to do it here, first control section was program program A. So it has the two symbols, list A and end A. So what was the address? What is the address of program A? So if you can get it, it is 4000. What about the address of the list A? It is what? 4040. What about for end A? It is 4054, because it is, if you observe, it is 4000 plus 54, 4054. And what was the length of this? It was 63, right? So this is what program A. When you take a program B, so what was the length of the program B? So you got 4063 is the length address for the program B. And what was the length of the program B? If you observe, it is what? 7F, right? Then it has the two symbols. Address of list B, from this you can make it out. It is 4063. You can make it out from this. 4063 plus 60. What do you get? 4063 plus 60. No, is it 60? Yeah. So you get as 40C3. So you get as 40C3. So when you sum up 4063 plus 70, you will get as 40D3, which is the address for next symbol. What is the next symbol? It is the end B, right? So this is what? A program B. So finally program C. So program C, address of the program C, it is what? 40E2, and the length it was 51. So length is 51, and it has two symbols, list C, address of list C. Again, as usual, when you sum up this 40E2 plus 30, when you do that, so 40E2 plus 30, so you will get as 4112. You got as 4112. So again, you have one more, which is end C. So again, as usual, 40E2 plus 42. 40E2 plus 42. So you got as 4124. 4124. So this is what I see it as. This is the final. Let me delete this, because based on these itself we generated this. So remember, this is the final ES tab. I call this as a final ES tab. This is the final ES tab which is generated after the pass one. So I call this as a ES tab. This is the final ES tab which is generated after the pass one. Now we are going to use this ES tab. We are going to use this ES tab in the pass 2. I repeat, we are going to use this ES tab in the pass 2 for loading and updating the object codes, which is very, very important to know. So now let us see that. So taking up the pass 2, so here if you observe, what we are going to do in the sense, we are going to do here the two major functionalities. One is the loading, second one is linking and modifying the object code based on the modification record. So for this again, let me elaborate in the same way however I did earlier. Again, for that also, you try to remember, you need to make it out for all the 3 input object programs, because it is also till the end of the input file, till the input all the files, not individual object program. So from here, let me make it out. So in my example, so I'll be setting the CS address with the program address. I hope you know that what is the program address in our example. It is a 4000. So it will become CS address is equal to what? 4000. CS address is 4000, because in our example program address is what? 4000. So CS address is 4000. Initially CS address is 4000. Then very importantly, I will be also setting execution address also to the 4000 only, right? So I will be setting the execution address also 4000. Then later then later I will be reading. So however I specified in one of my slide here, if you observe, so in the past one you consider only the header record and the defined record, wherein in past two you consider the text record and the very importantly modification record, that we are going to see now. So now, so as usual you load this, or so you find this again, you read the first header record and set the CSLTH. So I hope you remember from the object programs. So this is the object program of A, this object program A. From this object program I hope you got to know that, from the object program A, such as, I repeat, such as, see if you observe from this object program A, so from the header record you got to know that control section length is 63. Then you started reading the text record. You try to understand how many text records you have. You have the two text records here. So those two text records will be reading, and if you observe this carefully, so if you observe this carefully, as soon as you read the from the text record, you will be moving that object code to the main memory where it is from. So you will be loading from the CS address. What is the CS address? It is the 4000 plus the specified address. So what is that specified address? That I will show you. So it is 4000 plus specified address, from where you will be keep loading the object program into the main memory. So for this, let me show you in the next slide. Here I'll show you. So what I will do, I'll just insert one more table here. I'll just insert one more table. So let me, for your okay, no issue. So this is what the memory, this is what memory address, and this is what the contents. So I'll just merge all this. Merge. This is what the actually object code content, object code contents. So now, so I may start with the address 0, but I may start with the 0. Actually I may start with the 0, but there is nothing which is there in the object code 0, because if you observe my program address is from the 4000. So I'll just consider some dots here. So my program address is starting from the 4000. So remember that. So my program address start from the 4000. So this will be the 4010, and this will be the 4020. So something like this, it goes on like this. Whereas, but if you observe from the object program, so this is the object program A. So understand, this is the object program A, this is object program A, but even though the program address start from 4000, but the actually object code is available from 20. It means to say that from 4020, understand that it is from the 4020. That is what it says, that it is you need to keep loading from 4000 plus any specified address. So here the specified address for this example, it is 20. It is the 20. So 4000 plus 20, it is 4020. So from here the object code will be loaded. So what is that object code will be loaded? If you observe this, if you just observe this in detail, so what is the object code here? So I hope it is visible. What is the object code at the 4020? If you can observe, it is what? 03201D. So I'll say 03201 and D. So this is the first object code. But I hope you remember every block size is 4 bytes. So it is of only 3 bytes. So next object code, what is the next object code? Is what? 77. That is also belongs to the same block. So then again it is followed by 1 followed by what? How many zeros? It is 4 zeros 4. 1 2 3 4 4, followed by what do you have followed by? It is what? 0 5, right? 0 5, so it is already 4 bytes. So you can 1 2 3 4, yeah, 4 bytes. Then you will get as what? 0014. So then again nothing. So this is what the object code which is loaded from the 4020. Again this is what 4030. So which is nothing will be available, nothing is available right there. At the 4040 also nothing is available, 4050 also nothing is available, because if you observe here, if you observe, next object code is available from the 4054 again. So at the 5050, if you observe, it is what? 50515253. At the 54 you have the object code. What is the object code you have? It is what? You can observe this. This is what you can, if you observe, it is what? 4014, 4014, followed by FF, because here if you observe, it is what? FF, yeah. So that's what. Next you will have FF, again F6, that is followed by you have 0000. So this is what? 4 bytes go over. Again here you, yeah, let me check, 1 2 3 4, yes. Again you have here as 3F, followed by, you can see, you can keep looking to these object code. These are what I am loading. So again that is followed by 3F. After 3F you will have 4 zeros. So I have 4 zeros, right? So after 3F I have 4 zeros, not the 5 zeros. Yeah, 4 zeros followed by 1 4, 4 zeros followed by 1 4. So is it 4 bytes? Yes, 1 2 3 and the 4, yeah. So next at the address 4060 I have object code. What is the object code I have? It is FFC0. So that's what object code of the first object program, which is control section A, is loaded. The text record A, these are the two text records which is at the 20 and the 54. So it is from 4020 and 4054 is loaded. So we are done with the loading of the two text records into the main memory. That's what, if you observe, that's what this says. So from the text record, move the object code from the record to the location. Which location? It is what? CS address plus the specified address. CS address is 4000 for this example, and the specified address is what? These are the specified addresses at which memory location it has to be loaded. So now I'm done with this part. So I'm moving to the next part, which is the modification record, if at all, if there are. So here you have to be very careful. So here I have the modification records, something like, if at all if I have the modification record, that modification I is supposed to do it. What modification I is supposed to do it, it also depends on the modification record. Now in this example, from this example you need to make it out something that, from this example you need to make it out something that list B, list C, end C, all these whatever we have, at the same time you also have the address of these in where? In my ES tab. Address of them also I have in my ES tab. So those itself I will be using. So understand now. In my object program, so this is what the object program which is loaded in the main memory, nothing else, right? So what shall we do? We'll take up this modification record. In the modification record, now understand carefully. From the modification record, see this, at the 24th byte, from the 24th memory byte you need the changes. So at the 24 means it is what? 4024, not just 24. So 20 is 20, 21, 22, 23. So from here the modification is required for how many off bytes? For the 5 off bytes. But what modification is required? Understand I hope you are getting this. I hope you are getting this. So if you want, I can also make it something different. As what shall we do? I'll just I'll just place this table here so that you may understand. This is what before modification, and this is where I'll say it as after modification. See, at the 4024th place, so these are the bytes, these are the, you can observe, these are the 5 half bytes which needs the modification. But if you understand carefully what modification is required, what modification is required in the sense, it is what? Plus list B. So whatever the value of list B need to be added with this. Now for that, what is the value of list B? Try to get that. What is the value of list B? It is the list B is what? 40C3. Get that 40C3. I repeat, get this 40C3 and add with this. I already shown. This is what to be modified. Add with that 40C3. So what is this value? It is what? It is what? 0000. So 4 plus 40C3. When you add this, you got us what? 40C7. So it means to say that, so this value will become, what? 040C7. I hope you are getting this. So 404 is changed as what? Is changed as what? Let me highlight so that you may understand. So you can understand, this is the word which is modified, which is 040C7. Earlier it was this. So based on the first modification record, what was the first modification record? So you had from which address it is said and what is to be done also, it's already there in the modification record. Based on that itself, the linking loader is modifying. I hope you are getting this point. So the next, let me take up the next, which is at the 54th location, 6 half bytes. So where is the 54th location? So this is what? 50, 50123. Again, this from here 6 half bytes need to be modified. So these need to be modified. Let me color that. So these need to be modified. What modification is required? You just refer from here itself. If you observe what is to be modified, you need to add that with the plus list C. That's it, nothing else. For that, find out what is list C. What is the address of list C? It is what? 4112. So get that 4112 and add with this 14. So I'll say 4112 plus 14 is what? 4126. That's it, right? So I got as 4126. So this will be modified as 4126. That's it. So it has become as 4126. Next modification record. Take up the next modification record. When you take up the next modification record, so it is what? 57. At the 57, if you observe, there are 2 modification record. For that, what is supposed to do? So you need to add NC and minus list C. What I will do? Take up list NC and list C. So NC is what? 4124. List C is what? 4122. When I take up 4124 minus 4112, I got this 12, right? I got that 12. So that 12 I need to add. So understand clearly what I supposed to do. I need to plus and C. So for your understanding, what I will do, I'll take up this completely from this, from this. So I'll take up this FF and till here. That's what it says, because if you see the modification record from the 57, 6 half bytes. So FF, F6. Let me take up that directly. So FF, F6. Then for that I need to add. If you see the modification record, for that I need to add what? End C. What is end C? Find out end C. What is end C? End C is what? 4124. So plus 004124. Again I may get something. Don't worry about that. Again, what I supposed to do? Again find out what? It is what? List C. It is 4124. And what your object modification record says? Minus, yeah, here it is minus list C. So subtract that. So minus 4112. When you do this, you got some other value, but you may get something which is bigger value. Don't bother, just take up the 6 of digits. That's what 6 of bytes. So take up this, that is the value which is to be replaced in where? That is what which is to be replaced where? It is to be replaced in place of this FF 5F6. So what is to be replaced? It is what? 000008. So these will become what? FF will become 00. Again these will become 0008. So that's how. So this is also modified. I hope you are following. So this is also modified. I'll say it as, I'll just color that with a red color, whatever it is, getting modified, so that you may understand better. So it is a modified. Again take up the next object, next modification record. See for the next modification record. When you see for the next modification record, it is from the 5A, and what is, there are 3 modification records if you observe clearly. There are 3 modification records if you observe clearly. Plus NC, minus list C, plus program A. From the program A, 6 half bytes. So it is what? 5A. So from here, so it is 00003F. So I need to take up the next modification record, which is what? Yeah, where is it? Yes. So from 5A, I need to take up 00003F. So take up 00003F. So for that, what I supposed to do based on my based on my modification record? First, you need to plus NC. If you remember, NC is what? 4124. I got something, fine. Next, I need to do what? Minus list C. What is list C? It is what? 4112. So I got something. Again for that, I supposed to do what? Plus program A. Now I need to find out the what is program A. So let me find out what is the value of program A. It is what? 4000. It is what? 4000. Nothing else, right? So that, let me add that plus 4000. If you add this, what did you get? 4051. That you replace where? That is need to be replaced with the 40. See, you got as 4051. So that is to be replaced as these 4 digits plus this. So I'll replace this as 51 and these two as 4 zeros. Yeah. So I got as, see, I got as 000040. I got as 0040 followed by the 51. Even that also we need to be modified. So only I'm just making red everything. So because those also to be need to be modified. I'll show you those modification as well. So till here it is what? So it is modified. Now let us go for the next modification record. So there is a modification record at the 5D as well. This is what this this is what the 5D, not everything. So from here to here, this is what 5D. So just 14. And what are the modification records you have? There are the modification records like that, minus and B plus list B. There are 2 modification records for that, minus and B plus list B. So for that, let us do that. So first let me take up the value as 14. Again, what are the modification records? I repeat, it is minus and B plus list B. So for that, find out what is and B. And B is what? 40D3. So minus 40D3. I got something, fine. Then again minus 4D minus and B is done. Again plus list B. So what is list B? It is what? 40C3. So I need to do plus 40C3. So I got as what? 4. I got as 4, right? I got as 4. So that is need to be replaced. So this will be replaced as 0, 4. So that's what is done. Now let's see the next modification record, if at all, if it is available. So yes, it is available at the address 60 as well. address 60. For that, what is supposed to do? It is plus list B and minus program A. What is there in the, yeah, this is the black, let me make it because this is address, right? Yeah, so what is there at the 60? It is what this is what the value which I have in the that's what the value which is I have on the respective location, which is 60. So for that, what is supposed to do? Plus list B minus program A. What is list B? First of all, find out what is list B. What is address of list B? So address of list B is what? 40C3. So it is plus 40C3. I got something. Fine. Next, what is supposed to do? It is minus program A. What is the address of program A? It is what? 4000. Do that. Minus 4000. So you got some other very bigger value. No issue. Just take up the last 6 digits. So these are the 6 digits which are to be replaced. So these values will be replaced with what? Now I hope you understood what I did for the one object program. I did only for the first object program. Try to understand. I did only for the one object program, not for everything. I just did only for one object program. So what I did, so I just based on my flow, so I based on from the text record, I just pushed everything to the memory. Then wherever you have modification record, based on that I just altered based on the values, based on the addresses, reference variable addresses. This is what is done for the first object program. Then what it will be done in the sense, it will be taken care for the, it will be repeated for the next next object program as well. So how it will be done? So take up the next object program. So let me take up the next object program here. So if I take up this next object program, if you observe, this is starting from the 3.6, but this 3.6, does it starts with the 3.6 in the sense? No. But suppose what I mean to say in the sense, so the first object program itself will be from 4000 to the 4063. So the next object program will be started. So from where the next object code need to be loaded, in the sense it is from the 4063 onwards. I repeat, it is from the 4063 onwards. Whereas again, from where exactly it will be loaded, in the sense it will not be in the 4063, because if you observe, clearly, the object code will begin. Where is the second object program? Yeah, here it is. The object code will begin at the 36. You understand? This object program starting address would be 4063, but the object code actually begins at the 63. So it will be 4063 plus 36. 4063 plus 36. So when I add up that 4063 plus 36, 4063 plus 36, so it will be at 4099. So the second object program would start from this is what 4070, and next it is 4080, next it will be 4090. So in the 90 again as usual, so it is what 90, 1, 2, 3, 4, 5, 6, 7, 8, 9. See, these will be 2 empty. Then from here the next object program will be started. So here the next object program is, what is the next object program as of here? So next object program is, object code is what? 031 yes, 031 031. I have 5 zeros, 1 2 3 4 5, but I need to check it whether can I fit everything. No, 1 2 3 4. So these 2 zeros should come to this, right? So again, that is followed by, what is the next object code? It is what? 772027. So can I fit everything? 1 2 3, yeah, I can. Next it will be after 4090, it will be 40, remember it is 40A0. So here what do you have? So you will be having as 0515 5 zeros. 1 2 3 4 5. So is it 4 bytes? Yes. So this is what the first text record. First text record in the second object program I am talking about. So this is the first text record of the second object program, I repeat. Yeah. Next object program begins, next object code begins at, if you observe, it is what, at the 70. So it is something like 4063 plus 70. It is what, 40D3. So it will begin at the 40D3 onwards. So go to the 40, it is what, 40B0. Again it is what, 40C0. It is what, 40D0. So let me try to fit this yeah. So from the 40D3 actually, so D0 nothing, D1 nothing, D2 nothing. Again where will be having from the D0, what will be having, it is what, if you observe, it is what, 0 0. Again this is only 0 0. Again here 0 0 0 0, followed by FF FF F6. But can you fit everything? No, I think yeah, these two can't fit here. F6, right? Next you have all F's, FF FF. So I hope you can fit everything. Yes. Again here comes, you will be having as what, FF F0, followed by you will have 0 0. So again next it will be 40E0, where we will be having as 0060. So this is the end of the second text record of the second object program, right? So now this, in the same way, from here, from these also there is a necessity of modification record. Wherever there are the modification records, if you observe, so here there are the modification records, plenty of modification records as well here. So you have the modification record at the 37. So where here itself there is a modification record. So wherever there are the modification record, those need to be modified. So as of here, let me also reduce this piece, size. Okay, what has happened? So I'll just copy paste this. Yeah. So whenever, based on, I repeat again, based on these modification records, you are supposed to modify based on this. So per suppose if you take up the first one, so it's supposed to be plus list A. What is the address of list A? Try to find out the address of list A first. So address of list A is what? It is what? 4040. So that you need to add, because here if you observe, it is what? Plus list A, nothing else. It's just a plus list A. When you add that, what is the resultant you get? So here, this is where you get the resultant as, so instead of 10 zeros, so this will be 40, and again, yeah, this will be again 40. 10 instead of 4 zeros, you will get as 1040 again. So check it, is there any object modification record for the next address? It is what? You have the modification record at the 3E. So you have the modification record at the 3E. So go to the the respective address at the 3E you are supposed to find out. So the respective address which is available, so it is what? When you take up the 3E, it is something like this, 4063 plus 3E. So it is what? 40A1. At the address 40A1, this is what? 40A0. So from here there is a necessity of modification. This is what need to be modified, from here to here. What is to be modified? It is again as usual given. So it is what? Yeah, two modifications, plus NDA minus list A. So it is what? NDA minus list A. So NDA is what? 4054. It is what? 4040. When you do this, so 54 minus 40, 54 minus 40, you will get as 14. So this will become 14. So the next is next modification record. It is at the 70. So which is that 70? Find out that 4063 plus 70. It is what? 40D3. At the address 40D3. So from here. So if you take up, this is what? All zeros. So it is what? These 2 zeros followed by these 4 zeros. Whereas what are the modification records you have at that 70? So it is what? Plus NDA minus list A plus list C. You take up the current values and do the modification. When you do the modification, you will get as 4126. You will get the 4126 004126. You can try out. Then again, next object code you will get as 0000. Here this will be 08. You can try out. So you will get again, next object code will be 0004051. Next object code would be, this will be all zeros. Again it is what? 400. Whereas this will be 0083. This is what I just shown for the control section B. So just based on these values itself, because anyhow we have the current updated values from this this ES tab. So those values need to be either added or subtracted. That is already specified through the modification records, which is already as given by the assembler. Based on that itself, you keep updating in the memory. So this is what the pass to. So what you do in the memory. So remember, it is not the two copies. This is for your example, for your understanding. I did as a two different tables here. It is a single one. What it will do in essence, first it will load like this. Again, there itself it will be keep updating, which is modifying. That is what the second part of your pass to. So those are what the pass to and pass 1 and pass 2 of the algorithms of linking loader. So I hope you understand. Pass 1, it will only construct the ES tab. Again, the pass 2, based on the current addresses, you keep modify the object codes. But before that, you push everything to the main memory. Then based on specific address, you keep modifying the object codes like this. So I just shown for the control section A and B. So it will be continued in the same way for the control section 3C also. So finally, what will be the final thing in the sense? It will be like this. So you will have like this. So this is the final outcome or final after linking, loading, relocation, everything is done. This is the final output, how it looks like. After modification is everything is done, this is how it will be loaded in the main memory. So I hope you understand. This is the complete explanation of the program linking loader. I hope you understand. Thank you.